Simplification of Surds. Before we dive into the simplification of Surds, we first of all understand the basic forms of Surds. The basic forms of Surds. A sword will remain in its basic form if it does not have a factor that is a perfect square. For example, root 7. We first of all find the pair factors of 7. What are the pair factors of 7? 7 and 1. I don't think there's any factor. There's no number you multiply to give us 7 except 7 and 1. So these are the pair factors of 7. Now if you check the pair factors of 7 very well, you notice that there is no perfect square. 7 is not a perfect square. 1 is not a perfect square. What are perfect squares? Before we proceed, what are perfect squares? Well, 4 is a perfect square, 16, 9, 25, and so on. These are perfect squares. So 7 and 1, no perfect squares. So root 7 remain in its basic form. This is the basic form of 7. 7. And the second question, let's call it question number 2. And we have a root 8. What are the pair factors of 8? We have 8 times 1, 4 times 2 give us 8, yes, 4 times 2. So the first factors, this first one, there is no perfect square. 8 is not a perfect square, 1 is not a perfect square. Then we check the second factors. This is the second one. 4 is a perfect square. 4 is a perfect square. So this will be equals to, root 8 will be equals to the root of 4 multiplied by 2. Root of 4 multiplied by 2. So the square root of 4 is 2. The square root of 2 is not a perfect square, so it will remain in its basic form. That's root 2. 2 is not a perfect square, so it's going to remain like this. If we apply the multiplication rule, we can separate the two numbers. So this is having a separate root 4 multiplied by root 2. So root 4, 2 multiplied by root 2, same thing as 2 root 2. Then our third question, question number 3, and we have a root 60. 60 has so many pair factors. 60 and 1. What other factors? I think 30 times 2 will give us 60. 20 times 3 will give us 60. So if you notice the 3 factors, there is no perfect square. So what we do is we will look for a factor that can be broken down to a perfect square. I think 20, we can get a perfect square here, 20 times 3. So we'll go with 20 times 3. So root 60 will be equals to the root of 20 times 3. So we separate this root. We have root 20 times root 3. This is equals to this. So let's focus on the first surd. So root 20, what are the pair factors of 20? We have 20 and 1. Is there a perfect square? I think, okay, 4 times 5 will give us 20. Yeah, 4 times 5 will give us 20. So 4 is a perfect square. So this will be root 4 times 5. Root 4, square root of 4, that's 2. 5 is not a perfect square, so it remains root 5 multiplied by root 3. So the two roots, when they multiply, you have a single root. Two separate roots, when they multiply, you have a single root. So this is 2. 2 will be multiplied by the invisible number here, which is 1. So 2 times 1 will give us 2. Root 5 times 3 is equals to 2 root 5 times 3 is 15, right? 5 times 3, 15, yeah. So this is our answer, 5 times 3. So let's solve the last question. Say question number 4. Let's solve one more. Root 45. What are the pair factors of 45? We have 45 and 1, and we also have 5 times 9. 5 times 9 will give us 45, right? Yeah. So this will be equals to the root of 9 times 5. So the square root of 9 will give us 3 root 5. So these are the basic forms of surds. The basic forms of surds.